In this video, we're going to talk about the example configuration that's available in the documentation and how to use it. So the example documentation is found by going to docs.kumomta.com, going to user guide. From here, you'll see configuration, and inside that is example server policy. So the example configuration is an init.lua file that is there to provide you with most of the basics that you're going to be looking for when you first set up a KumoMTA instance. Obviously, it's not meant to be used as is. You are going to have to make certain modifications to it in order to be successful, if not to it, but to the helper configs that'll come along with it. We'll go over the file a bit here, give you the general layout of it, and from there, in a following video, we'll get into detail of the individual helpers that are part of this. So to start with, we're looking at our example server policy. Comes with, as it says, don't use it as is. Read the configuration chapter before you use the policy file. It's been written to opt KumoMTA etc policy init.lua, or where you're going to need to write it to. Require statements are needed in order to make the script run. It's just giving us our base libraries in order to operate on this. And then you're going to see that the helpers are being loaded as well. So one for traffic shaping, one for managing queues, one for managing the domains that you're going to accept messages for, one for the IPs and other sources of traffic going out, one to control DKIM signing, and one to do webhooks and other log hooks with. From there, we're going to start our setups. These are going to happen in a specific order, so please try to leave this file in the order that you see it. We're going to start by loading up the helper for sources, which is IP addresses that we're using for sending. Following that is the one for DKIM signing, and each of these has a path to the data file that it's going to use. From there is traffic shaping automation. After that, we're doing log hooks. Now, log hooks in this case doesn't have a configuration file because it's a pretty straightforward setup. What we have here is a basic one. You can comment this out if you don't need it. It's setting up a webhook. That webhook is being pointed at 10.0.0.1, port 4242, path/log. It's going to include the subject and the X customer ID headers in it. That is it. That's all it takes in order to set up a webhook for a given destination. This can be instantiated multiple times, set up with multiple webhooks. So this gives you the ability then to set up as many webhooks as you need in order to achieve your purposes. From there, we're setting up the queue helper. You'll note that the queue helper comes after the webhook and shaping helpers because they all touch certain code paths together, and that means that the queue helper has to come last, otherwise it will cause issues with the other two. So that's why you see this very specific order. Queue helpers here says set up the queue module and path again to where we have our config for queue management. That's the end of everything standing things up. After that, we get into event handlers. Now, the event handlers, rather than just running once when the file comes up, they're run based on hooks that occur within the server. The first one is the init hook. The init hook is when the server first starts up. What are we going to do here? The basic groundwork of setting up our server. Where's our spool located? What format does it use? We're using RocksDB. There's also just file system available here, but we're not going to get into that. RocksDB is faster, it's more safe as far as giving you a balance between performance and stability on the disk. Going to file system sacrifices a bit of the performance, but in turn gives you that right after every message. RocksDB is a very good balance as far as this goes. From there, we're setting up the traffic shaper. So shaper, set up publish. This is going to say, hey, we need to get ready to be able to send information to the TSA daemon. It's a separate process that runs for traffic shaping automation. After that, we say we're going to configure our logs. We're writing to var log KumoMTA. Each segment we write, because we compress these out of the server, each segment is a minute long, so it will take up to 1 minute for you to be able to tail the latest elements that have been added to that log file or to be able to rotate that log file. From there, we're setting up our bounce classifier, setting it to the standard KumoMTA share iana.toml file. If you have your own rules, you can add a second file and you can put them in there. If you want to use it just the way it is with what we provide and what we update with every release, then you leave this as is. We're starting our listeners both for HTTP and for SMTP. So we're listening for port 8000, port 8001, depending on whether we're using TLS or not for injection. These could be commented out if you don't want, for example, an insecure, or if you only want, the ability to do it with an insecure, or if you're just not going to use HTTP at all. Keep in mind, this is not just for injection, it's also for server status and management APIs. So it's worthwhile to leave those in there, at least in the secure format. From there, we're starting up our SMTP listener. That's on port 25. Our host name by default, we're going to say hello as mail.example.com. Obviously, you would change this to the host name of the server that you are installing. And we're adding a relay host list. And what this is saying is we will accept injection traffic from either host 127.0.0.1, so localhost, or anything on the 192.168.1 network. Anything from outside of that is not going to be permitted to be relaying messages through the server by default. And then from there, we're starting an ESMTP listener as well. This one is on port 25 for IPv6 and for essentially localhost on IPv6. This is commented out. This is for shared throttles. If you are running more than one server and you want to be able to share throttles among the servers so that you can represent a single IP through multiple machines, then you're going to set this up to use Redis as a shared cache for those servers. We do not enable that by default because it involves additional setup steps and most users are installing on a single server. After that, that ends the init event. So that's everything that happens at server startup. The way KumoMTA works is it lazy loads the additional information it needs to make decisions as it relays messages. And so this means that rather than having all of that configuration preloaded into the server and requiring a lot of server restarts or reloads when you make changes to your config, as well as a lot of memory space to keep track of everything, instead we load configuration options as we need them. So the first one that comes up is get listener domain. That's saying, hey, we've received a message. It is being addressed to a specific domain by an outside server. What do we do? How do we make our decisions? And so this is saying, when that event fires, use the listener domains helper, which is being configured by this particular file. It will then take care of providing the appropriate response to the hook. This will repeat through all the other events that we see. So get egress path config is saying, hey, I have a message that needs to go out through a certain egress path. I need to know what the options are and how that is set up. And so here again, we're saying, okay, when that occurs, go to Shaper and have it take care of that. That's the traffic shaping automation helper. And so that helper is going to return back and say, all right, if you're being told to use this egress path, then these are the options that you should use as part of that. And that includes, for an egress path, where the message is going and which source it was being told to use for sending that out. From there, we have two events, one of which is SMTP server message received. So we've had a message injected over SMTP. We need to make some decisions. We need to do some adjustments on it. First thing we're doing is protecting against SMTP smuggling. So we're saying we're going to check this message for conformance to certain RFC 5322 rules. In this case, we're looking for the non-canonical line endings. So we're saying, are there any just single line feeds instead of carriage return line feeds? If we see that, in our case, we're going to catch that and we're going to reject the message saying that that was the problem that we had with it. If you wanted to fix it rather than just block it, you can move this element below to this set where it would be then saying, I want to just correct that. We start out by giving you a default of simply rejecting the message because that gives you the opportunity to identify that issue and hopefully fix it in the injecting application rather than blindly fixing it where you'll never know that there was a problem system in your environment that was causing that to happen. After that, we go to the queue helper and say, all right, I need to set up the queue for this message so that it can be routed through the server. So I want the queue helper to run and apply its logic against the message. And after that, we DKIM sign. DKIM signing always comes last because if it comes earlier in the flow of processing a message, there's a possibility that it will apply a DKIM signature that could be broken by later changes to the message by code further down in the flow. Finally, we have one for HTTP message generated. In this case, because we are taking it from an API call, we're not worried about line endings. The API system will always fix and format line endings correctly. So we're just doing our queue helper and our DKIM signing. That's it in a nutshell. So to use this in your installation, you've installed KumoMTA according to one of our previous videos. You go here for our little copy element, copy it to the clipboard. From there, we're going to go into our SSH session to that particular node. We are going to change directories to opt kumo etc policy. Within here, you'll notice we have two files, init.lua and tsa_init.lua. So we are going to edit, in this case, init.lua. Within that, you'll see that we have a file here to begin with. I'm just going to clear that out, put us into insert. I'm going to paste in that file that we saw earlier. We're going to right-click that That is now our configuration file in place. Obviously from here we could go through and edit it, changing host names, changing some of the settings, and then we're going to go in a follow-on video and show you how to put all of those policy helper config files in place so that you're able to get the full configuration set, and from there we'll show you how to start the server and troubleshoot. If you have any questions, feel free to join us in our Discord. KumoMTA.com/Discord is where we have a Get Help channel that you can ask questions. Obviously, you can also ask in the comment section below the video, but for real-time assistance, look to us in the Discord.